Hello everyone and welcome to today's TRUMPF webinar on the subject TecZone Design and the fastest way from solid to unfold. My name is Vitaly Pautz and I'd like to present you today TruTops Boost and why it is a smart programming system with cutting-edge 3D design capabilities. Let's remind ourselves how is TruTops Boost different to our current TruTops and to other systems. We have developed a completely new system with integrating all the technologies such as bend, laser, and punching programming. And you see, basically, the formula is very easy of TruTops Boost. It's the Boost technology containing all the automatisms and the new architecture plus the new operating philosophy, meaning we have divided the software, the programming process into two steps. And first step or first level is the whole so-called home zone. It's our central control level and also order management. And basically very central is the boost button, and you get to your INC by clicking the boost button and starting the automatic calculations. And the second level is our TecZone, containing all the technologies and for the first time a 3D CAD system. And basically you're able to correct any corrupt CAD data and import all the major CAD formats. And another advantage is that you can interactively change or adjust your the automatically generated solutions, technological solutions, and that's basically everything within the TecZone level. And at the beginning, it's always the order, and the end is the INC file, which you transfer to your machine. Let's have a first look on the problems from the design of sheet metal parts in general. So apparently, sheet metal design is often overlooked in 3D CAD systems, and it's quite difficult sometimes to handle dump, step, or IGES geometries, and therefore the optimization of the production often requires a complete reconstruction. And that's, of course, very time-consuming and tedious. And there are, if we, for example, think of prototyping, there are always quite late design changes within the product development state or process. And CAD systems don't allow very often to make late design changes, and it becomes quite difficult. And with TruTops Boost, we meet all those problems, and I'm looking forward to show how we have solved it within TruTops Boost. And here are some advantages listed of sheet metal designing with TruTops Boost. And first of all, of course, we import and unfold non-native designs. There are special features which can be introduced due to modern tools, and the unfoldings can be even further optimized by introducing various bend junctions or beads, for example. And again, there are many options to create and modify sheet metal parts. All right, let's switch over to TruTops Boost. And as you can see, here is basically our user interface. On the left side, there are categories and some filters. In the center part, there's the order list, and on the right side, a detailed view of the selected order on nesting or single part, depending on which category we are. So first of all, we import some files. As you can see, there are some SolidWorks files, STEP, IGES, DWG files, and that's the list of all the supported formats. So TruTops Boost is CAD neutral, you can say, and we support all the major CAD formats. So let's select all the examples and import them. So with one glance, you see the new status concept. So you always see the next programming step if you check these icons which are there on each order, and you see that there's a warning with the design, so we need to do something with the design. Of course, we haven't boosted the order yet, but we will do it later. But we can see already that it's basically the next step. So we set for all the imported orders some attributes. So that would be the finish date. Let's say it's next week. We set a quantity of, let's say, 3, and we set a customer. And what we also can do is we can assign a material for and a tool list for the unfolding. And we can leave the bending machine and boost all the orders. So right now in the background, the parts are being imported and also already corrected. By correcting the parts, there are, of course, some rules which are applied in order to correct some geometry corruptions, such as, for example, stitching faces together to a solid between others. And of course, TruTops Boost tries to unfold the files. And if there's an assembly, and we see it very nice here, there is always a warning. So if you see that exclamation mark, a red one, you know there's a problem and I need to take care of that. So what I'd like to emphasize is how easy it is to solve geometry problems, and if the unfolding is incomplete, how you do it in TruTops Boost, and basically there's no problem which can't be solved. So we will open the first file, first example, and see where the origin of the problem is. So first of all, we do have a task panel where the problem origin is stated most of the time, and of course the file is being analyzed, and if we have implemented very mighty repair tools. So if you don't find the problem, it's quite easy to activate some of the repair tools and just to see whether, for example, free form curves are there, so non-mathematical faces, and of course it also can be. And we see here that there are unidentified bends and formings, and of course we see it also just by looking at it. There are some beads, there are some screws, and so on. And for that reason, we have a quite handy tool called Identify Forms. And first of all, we click on the form identification. Now the model is being analyzed, and all the forms, which are basically, if you check the lower and upper side of the unfolded sheet metal part, everything what is beneath or higher than the upper side is recognized as a form, and even cutouts can be analyzed, but we ignore them in that example. So now we see that 15 forms were detected, and they're in red. What we do is I just select the screws, the 6 screws, and I identify them as a form, and you see that they get orange and get a form feature. So for the other beads, I'd like to use that bead identification tool, and you see that there are 9 beads identified. They just click the check mark, and they also get the feature bead. So the bead type is circular, and there's a radius and a round radius. All right, so we have identified some forms, and what we do is we validate the geometry and check whether the unfolding is correct. If the unfolding is correct, you see it immediately within the structure tree. So the unfolding was created. We just open it. What we can do is we can place it in a split screen and, for example, check what happens if we change a certain radius. So if you pay attention, I have selected A10. There's a bend radius of 2.2 mm. So if I change it to 1 mm, for example, you see that 681 is of course being changed to 683, and so meaning that the deduction values and bend allowances are drawn out of the database, database, and we just change it back to 2.2, and it's again directly modified within the unfold. So both views are connected, and it's quite easy to work on both sides. So we close it again. So what I'd like to show you is are some special features if you want to produce that part, for example, out of 3 parts. How do you do it? So first of all, I click 2 bends where I want to make this separation. I split it, and I'd like to introduce a tab. So if I activate the tab tool, I need to select an edge, and you see there's a preview. There are some geometry dimension settings, and I'm happy with the default values and just click the check mark. So in that case, you would probably produce the part cheaper. It's out of 3 parts, and that would be one possibility of doing that. So if I select that face, click on Unfold, you see immediately how the part would look like within the tab region. So on the other side, I'd like to repeat it and use another feature, and it would be a hinge. So again, I click on the edge. You get a preview. You can modify your dimensions of the hinge, and of course you need the right bending tools, but you see how the part would look like. So the modern tools within TruTops Boost help you to produce your part not only correct and according to sheet metal rules, but also you can modify it and make the part even cheaper. And we can just move it and to see, for example, how it would connect to the rest of the part. And again, the unfold, if you just click on that on a face, on a part, and unfold it, you see how it looks like. So our second example would be that assembly we just opened up, and I'd like to show just we see if we check the structure tree that there are 6 components, and I'd like to unfold that part. So I locate it within the structure tree and open up that component. So as you can see, there are quite many rounds. There are no splits and doesn't seem to be a sheet metal part, but it's very easy actually to repair it. So I just select the 1 radius and I look for all equal radiuses and press F for fill, and in order to get edges, sharp edges, and fill also that radius. So with the power selection tool, I have selected with a few clicks all the radiuses, and what I do now is I just convert that bulk and assign no overlap to those 4 sides, box select from right to left, and also those 4 edges at the bottom. Well, the rest will just get the normal bend And you see that just with a few clicks, we have converted the whole part to a sheet metal part. And we just check the unfold and look whether it's unfoldable. Well, it's not unfoldable yet, and the reason is you get also the interference because it's not splitted at the bottom. So what do we do? It's very easy. You see, for example, that side, and we've got a function called split. I just want to type in 50%, so it gets the center of that corner relief, and you see that it cuts all the way through the bend until a certain area. So last step would be separation of that bend into, let's say, full overlap, and we see what happens. If you don't like if you would like to choose the other side, you just reverse the sides and, well, it's done. On the other side, same game. You go over to your corner relief, type in 50%, you get a cut, and you just select your bend where you change from bend to full overlap. Well, for the other sides, it's even easier, but there we use another tool guide with the two cutter points, and here you just select the 2 points where the cut or the split should be inserted, and also go to the other side and repeat. So now we can check whether the part is unfoldable, and as we see it is. We see the outer dimensions, and we can check the corner reliefs if they are okay. We just close the part, close the component, and you see that the part is converted, is unfolded, and we can take care of the other parts. But I just close it and show you some other examples. Alright, we check our third example. I just open up the next part, and we see actually immediately that the conversion wasn't successful, and we just try it again, and alright, there were some corner reliefs introduced already, but the system wasn't able to split the whole body, the whole structure. Well, first of all, I would like to power select all the corner reliefs and fill them in order to get the right splits, and you see that all the corner reliefs were filled. And again, I click convert, I select the right junction type, choose no overlap, and just see where I'd like to introduce some splits, and let's say it would be on those sides. And on that side, and here in the front, maybe those 2 lines. Well, you have, of course, to think how you want to produce that part. Well, for the rest, just have chosen the bend junction and have selected all the red lines. I validate the geometry again. I check my unfolding and click unfold, and we see that everything is unfoldable. Well, just to check some corner reliefs. For example, if you see some corner reliefs like that one, it's quite easy to correct them. So you just select, hit fill, and the corner relief is being filled. So of course the automatic preparation is very useful. So that relief should be there. So I just reverse it. but the boost gives you full control with the manual tools. So just correct some reliefs you don't like by selecting them, hitting fill, and you see if you close the part and see how nicely the corner reliefs are. Of course, if you like, you can work it out in 3D, but often it's easier just to open up the unfold and to correct the corner reliefs there. Alright, we close that part and check the next example. So our next example is an IGES file with two problems. There are invalid geometry structures and some bendings which weren't recognized. Well, we open up the part and we see where the origin of the problem is. Basically, I see that the whole structure is one surface, so there are some faces missing. I can basically clip volume or zoom to fit and go through the problematic areas, and I see that those holes are the origin of the problem of the gaps. So I just hit the check mark and I let all the gaps being filled, and now I see that we get a nice solid, and we try to unfold now. All right. So we can validate the geometry, and I see, just check whether all the bendings are without any interference. Well, if you look very closely, we see that there's an interference in that area, and it's very easy to solve it. We need to find, of course, that the triangle, and that would be that area. And well, I just hover over to that face surface. I just press Control, turn my mouse wheel, and can basically select the face behind any other face. So I pull that one by, let's say, minus 1.5 mm, and we should see a gap here. If I activate the front view, I see it's has been moved, and of course I can still drag and drop it or drag it back by just pulling the face. And yeah, set another distance as basically I wish. So we have solved it. I click validation on validation of the geometry, and if the calculation of the bending program is active, the unfold was correct, and we can close that example. So let's do a last example, that clamp. And as you can see, the conversion of the file of the model wasn't quite successful, or in other words, as you can see, not all bands were recognized. So first of all, of course, I can check the unfold and see, all right, in that area, that's basically the origin of the problem. I close it again. And if I zoom in, I see that the side walls are basically like sticked to the main geometry, the main model. In that case, again, we apply our trick. Basically, what I do is I select the inner face, copy it, paste it, do the same on the other side, double click, and all the faces get selected, copy paste, and we introduce just two planes on that side. So first of all, let's select the face, or
yes, the surface where I want to insert my plane. And what I want to do is I just cut the object with those two planes. And basically delete those solids on the side walls. So the next step after cutting would be positioning of the faces to the right position. Therefore, activate the move tool and displace the anchor and basically move the face to the right side, and I'll do the same on the other side and just select the whole surface. I move it to the upper side. Now we use the pull tool in order to thicken that surface, and I just drag the surface and you see how they get merged. And I'll do the same on the other side. By pulling it, you see we get now one solid. We delete the plane and the wrong unfold. And in the last step, we just convert the whole file and we check the unfolding. And as you can see now, it was unfolded correctly. Alright, that was my last example. I hope you liked it. We have seen how we solve different kind of problems which might occur within the unfolding process, and how we can easily correct 3D geometry problems. To sum it up, TruTops Boost works as expected. You just sketch on parts and pull and move to adjust the part. There are no CAD restriction and rebuild problems. Boost works with any CAD geometry, and the job is done faster than ever before. In case of any questions, don't hesitate to write us. We are glad to answer them. And just a short preview for the next topic of the webinar, it will be TecZone Bend and how we do the bend programming easier than ever before. And if you have got any ideas, also feel free to give us a feedback. And I'm looking forward for the next webinar. Wish you a pleasant day and goodbye.